In this video, we're going to look at some application problems that involve inequalities. Our key that this is an inequality rather than an equation is in the wording of the question. So we're going to look at just the very last sentence here, the second bullet point, and we see the words at least. And so that tells us that 50 pounds is a minimum and we really want 50 pounds or more. And so we're going to be using that idea of less than or equal to, greater than or equal to, because of the wording of this question. So I'll make my question smaller, and the first thing we want to do is just go through, pick out important information. So I see that there is a brand A and there is a brand B of fertilizer. I love to garden, so when I go to the gardening store, there are different brands of fertilizer and they each contain different ingredients or different nutrients. Some tell me on the package that they're to get great flowers, others are to produce vegetables. So here we have a farmer and he wants to mix the different brands to create his perfect blend. So I'm just going to make a chart of data. So I have brand A and I have brand B. In brand A there's nitrogen at 18%, phosphate at 24%, and potash at 12%. Next sentence, brand B, 5% nitrogen, 10% phosphate, 15% potash. So just setting up the problem. Now I'm ready to look at the question, and it asks me how many pounds of each. So that idea that we have pounds of each is telling me that I'm going to use two variables. So because A comes first alphabetically, I'm going to let A be X, and that's really X pounds of brand A. I'm going to let B be Y, and again that's really Y pounds of brand B. And then it really is only concerned about in this question the phosphate. So we're going to focus in on the phosphate in order to write my equation. We see that the particular farmer would like 50 plus pounds. So 50 plus pounds of the phosphate. And so however many pounds of brand A we use, it's not all phosphate. It's only 24% phosphate. So I'm going to change 24% to a decimal, so 0.24, and multiply that times X, because the word of usually means multiply. So 24% of the pounds of brand X. I'm going to add to that what we use from brand B. So that's 10%, so 0.1, changing 10% to a decimal, of Y, and again we're going to multiply. Now if this was an equation we'd put equal 50, but we want this combination to be at least, so greater than or equal to 50. Now in order to graph and solve this, I'm going to need to change it so that it's in slope-intercept form, or solve for Y. So I'll subtract 0.24x from both sides. And that gives me 0.1 y greater than or equal to negative 0.24 x plus 50. So I still need to divide on both sides by the 0.1. So divide by 0.1. Make sure that you divide every single piece by 0.1. So be real careful with that. And so then this gives me y. It was not a negative division, so my inequality sign stays the same, so greater than or equal to. And I did this ahead of time on my calculator, so negative 2.4 x plus 500. And you're welcome to do those divisions on your calculator. So make sure my decimal shows up there. Next thing I want to do is I want to actually get a graph for this. And I know that this would be the equation of a line, and then because of the inequality that is going to have shading. So I'm going to go to my graphing calculator. So here in my graphing calculator, first thing I do is go to my y equals screen, and then I'm able to type my equation. So negative 2.4x plus 500. And I can change my calculator to graph an inequality, so I'm going to arrow back through here until I'm at the symbol that comes before the y1, and you can see it blinking there right in front of the y1. And then I'm going to push enter, and each time I push enter the symbol will change. So currently it's at a line. There we get a thick line. There we have shading above, and that's what we want because this is y greater than or equal to, so we want shading above the line. And so that's the symbol I want. The next thing I'm going to do is set up my window, because with a number like 500 for my b value in slope-intercept form, my intercept is way up at 500. So go to my window, I'll let the -10, but I'll change my x max a little higher than 500, so I'm going to go with 600. And coming down through, I'm going to change my y max as well to the same number, a little above 500 to 600. This may not be a great window, but it's a good starting point to pick a number somewhere a little above the biggest number that you have in your equation. And so then I hit graph, and you see my calculator graphing and shading. And so this is my answer. So I want to take time to go to my paper and actually draw a sketch of this. The sketch will be slightly different than what you see on the calculator, but very, very close. I'm not able to keep my calculator on my window while I'm drawing. So we have that image in our mind. So we have the y-axis and we have the x-axis, and we really are in the first quadrant, so I'm not drawing all of my quadrants equal. And then we have our line coming down through here, and it is a solid line because of the equal to aspect. We know that this intersection point right here was up at 500. Our shading is out in this area, so all of this is shaded. Now, something to consider when we're doing application problems. It doesn't make sense that x and y, our pounds of fertilizer, go below 0, so it doesn't make sense to be in quadrants 2, 3, or 4. So when I do my shading, I'm going to stop my shading at the axis, both places here. So this little section right over here, even though it's above the line, I'm not shading it because it does not make sense to have negative pounds of brand A. And the same thing down here, this bit is shading below the axis but still above my line. I'm not going to include because it doesn't make sense to have a negative amount of brand B. And so my solution set, the number of pounds, would actually be any ordered pair out here in this shaded region. And so lots and lots of choices of how much fertilizer of each brand, and even though I sort of draw a line here to like make an area, this really extends up to infinity, out to infinity. There's no boundaries around it. Something to consider. In this problem, we didn't talk about the nitrogen or the potash, and most likely there are minimum amounts for those and also maximum amounts for them. I know nitrogen in particular, if you have too much nitrogen in your soil, it sort of burns the plant. And so what we would have to add into this problem are both minimum and maximum restrictions. And at that point, we have what is called a system of inequalities, and that's what we're going to be studying in our next lesson. When we add more inequality lines to this graph and further limit our shading so that we end up with a very small area that is our feasible region, that small shaded area would be the ordered pairs that meet all of the restrictions. But in this case, as our beginning, we have here in our shaded region ordered pairs that meet this one restriction on phosphate.